This was the point where my mum finally understood what I did. We need to have common metrics so that in future we can give researchers credit for all of their open outputs. The academic publishing setup and reward setup is very complicated, and there's lots of things that are confusing about it.
Thank you for joining us again. This is a continuation of the previous episode. As always, here's your host, Nikesh Gosalia.
So why do you feel opening the scientific data to the world is so important, especially, what we maybe term it as negative data?
Looking back on the last 10 years, I think two areas where I think there hasn't been as much progress as I'd like, where there has been fantastic progress elsewhere, is, if you see the growth of green versus gold open access, 10 years ago, there was about the same amount of green open access, making a free copy available somewhere of your paper, versus gold open access, paying the $1,200 or to $12,000 fee. And it's definitely been an explosion of gold open access over, I think there's 2.5 times as much gold open access as there is green open access now. That's frustrating because it's not perfect in the equitable future world, but I'd say, hey, I have access to a lot more of the content now, which I wouldn't do otherwise because I'm not affiliated with the university. So, there are some compromises. And I think the idea of negative results getting published is a huge inefficiency in research. That's one area that I don't think has come as far as it could do. And that's because I think the data credit system, the credit for all of your research outputs is, it works to a level, but at the funder level, it's not quite there yet. And it's really encouraging to see that it is happening. So the National Institute of Health are funding repositories to start interoperating with each other and promoting things around their new policy. And so I'm the co-chair of one of their working groups, which is the Open Metrics for Data Publishing Group. And what's great about that is they're saying we need to have common metrics so that in future we can give researchers credit for all of their open outputs, because it's very hard to normalize everything. Previously we had one type of content, the paper, and the paper will always remain the king. It's the or the queen. It's the context. It's the story of what you did. And then we have, one or two measures of impact. The citation count, potentially, where it's published, which I'd like to move away from, but such is life. You can't pretend that things don't happen, right? You can't pretend that there isn't. I love DORA and things like this. I love what Randy Sheckman did when he won the Nobel Prize about saying, let's not all just focus on publishing in Nature. But at the same time, pretending it's not a thing just makes life harder for everybody working in the space. And so negative data is something that I think there is going to be more credit for in the future. But the reasons why it's important, right? I touched on COVID, right? This was the point where my mum finally understood what I did. If it wasn't hard enough with stem cell biology back in the day, she just used to tell her friends that I work on the internet, because open academic data publishing is a bit niche if you're not in the space. With the publication of data sets associated with COVID, I think the worst term in any paper is data available upon request. There was recently a study that showed that if you actually chase those people up, I think it was 7% got back to you. And I like the idea of emailing. It's easy to do now. Finding everyone who's got data available upon request in their papers, emailing them and ask for the data. And if they say no or don't get back to you, then you can just go to the publisher and say, hey, can you retract that paper? They're not doing what they said they would. But that person would have a death wish, probably, knowing the current academic battle that's going on. But with COVID, it was easy. We are trying to get to a vaccine. If people make their data openly available so that people can build on the research that's gone before, we can get there quicker. If this time axis gets longer, then more people die. So the ways we can make this time axis shorter is to have all the content openly available, all the papers openly available, all the data openly available, so that researchers don't need to send an email to somebody saying, hey, can I have access to your data? Because all it takes to slow that down is it doesn't even need to be an active dissent. It's just passive. They just don't reply to the email. And then that time axis gets longer, more people die. So if all of the research is openly available, then we can build on top of it and move further faster. With the idea that COVID was a one-off in that well, people understand that because it was an emergency. We have the Sustainable Development Goals, and I think every one of them is an emergency, right? You've got climate, you've got poverty, you've got people who are going to be living under water levels. So all of those things should be an emergency that we're focusing on the research community making all of their research data openly available. That's point one. It was a very long point one. I have a point two as well, which is this idea of the machines doing all the work for us. And something that came about 10 years ago. There was a book published called The Fourth Paradigm in 2009 from Microsoft Academic Research, led by the late Dr. Jim Gray. And he had this idea of if all of the papers and all of the data is online, then we can get to this next level of research. And that's the computers doing all the grok work for us. So machine learning, AI, human brain processing power is never going to be able to look at every single paper, every single data set to look for trends and patterns. But if you can get the robots to do this for you, then that combination of robot and human together can push us on to the next level of knowledge discovery. And I think that's the coolest thing about what the next 10 years of academia looks like.
Fantastic. This is really just thought-provoking. What I have personally noticed over the last maybe 3 years perhaps is that the whole narrative around use of technology is definitely, kind of changing. The people are more open to listening to ideas. People understand that technology is here to augment what we do and not really replace, like you correctly mentioned. But just from your perspective, Mark, I mean, what have you been hearing? What have you been experiencing as far as, use of AI and machine language and perhaps, blockchain is concerned? And then just very specific to Figshare, perhaps, what kind of technology is involved in delivering, Figshare products, and what kind of, development's been happening?
Yeah, it's interesting as well, right? Because you have the different stages of company growth. And my developers will hate me saying this, but when I talk about what we do now, we build policy compliant infrastructure. And the cool stuff, the open research, the open access, the cool stuff that can build on top of it is a secondary to we have to play the game with the organizations that exist. So if we're working with universities in South Africa, the data needs to live in South Africa. Regardless of the point at which it's published, it can become, it's available for everybody anywhere to download. Fine. But the government has a rule that the data needs to live in South Africa for very good reasons over the past. So we need to make sure that that's happening. So what we have built is, and this is true of Australia, in Europe, certain universities can't use American-owned companies as our default cloud layer. We use AWS, Amazon Web Services. You can't use that for some European universities. So we use a German version called Hetzner. So we have a multi-site version of Figshare built all over the world, which is cloud-based, rolling updates. So we're adding new functionality all the time. It's always with that ISO certified, compliant, this is going to be around a long time. This is resilient. There was a story about a famous researcher whose thesis got made available on a university platform. And the headline was, it was so exciting, it crashed the platform. And I understand that as a news story, but I would be devastated. That it's like, well, there's more people looking to take an interest in something that's really niche and really interesting, and I think a good thing for humanity to be looking at. And the fact that lots of people couldn't have access because technology fell over is for me not good enough. And so it seems boring on that level, but it's very important in kind of feeding this next level of stuff, of open content for things to be built on. In terms of some of the things you mentioned there, yeah, for me, the most interesting role for blockchain in DeSci, as it's called, decentralized science, is all about this access control. And I think there's loads of I think we'll see a lot of innovation in that space, PhD certificates, master's certificates minted on blockchain so you can carry them around with you. A lot more trust, a lot more authenticity in the space. I do think that in terms of machine learning and AI, very close to where we live, is this idea that the human and the machine are better than the human alone or the machine alone. Like we see this with chess, right? That the best players of chess in the world are the human with the machine. That will beat the machine. That will beat the human. That's why we've seen it in the news recently about are people cheating with machines in the chess world. And I think that's true about academia. And so it's been amazing. The biggest revelation for me in the last Google DeepMind project called AlphaFold. So this is the AI company that originally got famous for beating Go, which is some very complicated board game that I've never played before, so I couldn't possibly tell you how it's won. But then they took on protein structure folding and this idea that you can predict a protein structure based on a text string. It was just an unsolvable problem. In 50 years of research, very expensive crystallography research, we'd got to something like 17% of the proteins involved in the human body. And overnight, AlphaFold came out and said they'd got to 99% of the structures. And it blew my mind. And I remember thinking at the time, this is going to win the Nobel Prize. This is a real step change in the way that, as I mentioned, Jim Gray and the fourth paradigm was thinking about before. And since then, in the year since then, they had 1 million structures. They've now got 200 million structures. So it's really just insane what's happened in that space. I actually emailed the lead author on the paper, a guy called John Jumper, to say, we're working in the data space. You got some very specific protein data. We really care about improving metadata because we have such a mess of heterogeneous data, and we want to make sure the metadata is better. And you mentioned fair data at the beginning, the F of fair, findable data, because a lot of researchers are new to the space and just call their data set. How do we get the metadata good enough so that AI will one day eat all of the data and spit out new things? And asking what specific schemas to work on. And they were just like, we're working on everything. So we need to move the space forward. It also raises a slight problem. I don't know if it's a problem. I think it's a conversation to be had. I saw a graph recently from a report called The State of AI. We do the state of open data every year, so I was reading the state of AI. They said that in 1960, all AI and machine learning algorithm innovation was coming from academia, and now it's basically zero. It's a rounding error compared to the innovation that's happening in the private sector. And working in the private sector myself, I can't be calling people out, but I think it is something to think about given how important it's going to be in the next 50 years of humanity.
Just, aside from the work that you've been doing, Mark, and things that you've been following, do you know of any other open science initiatives that excite you?
In terms of open research, I think about it as this, collaborative landscape and how that's moved along in the last decade and what have you. And we were talking offline just beforehand as well about a sister company of ours at Digital Science in Overleaf and how explosive their growth has been in just better collaboration tools for researchers. I know it's not all open, but I think that open way of working just really helps set people's ideas from the beginning that we're openly collaborating on this. People openly collaborate on code using GitHub and GitLab and Bitbucket. And I think those tools are really important. One thing I've seen in the last few years as well, again, COVID reference, is this idea that everything's moving to more online workflows. It's been a great movement in terms of innovation because, things like this are much more accessible now. Everybody knows how to use webcams and all of this. And what I've seen really interesting recently is a company called Cassini, which is a company that looks at lecture series. And again, it's another kind of uncaptured output of research. We have this thing at Figshare where people make available their keynote slides where they had 100 people in the audience and they get 10,000 downloads. So it's exploding the impact of your research and who gets to see that. And I think lecture series and presentations in general are ripe for innovation. And what Cassini has done very well is these making use of what you were saying before, making use of technology to improve the space, not replacing anyone's jobs, just doing innovative stuff. So they have this engine for throw in a video and some presentations and it pulls out all of the references. It just academicizes it, in the same way that Figshare will make sure it's persistent and make sure it's got a DOI. It's a few little tweaks that YouTube is never going to do, which is why you shouldn't put your videos on YouTube. GitHub's never going to put DOIs on every item that they have because that's not their core model. The tweaks that we've done, I think Cassini is doing some really interesting things in terms of making content more accessible to more people. And I think just having lectures available in a machine readable way means that knowledge discovery becomes a lot more interesting.
Why do you think some institutions are slower to adopting open science models? What's preventing, say, mass adoption, in your opinion, Mark?
I mentioned before about different countries having different rules. I also mentioned this report we just brought out called The State of Open Data. We've done it for the last 7 years. It's a survey of researchers' thoughts and trends around what people do around open data and open science. The good thing about it is they're kind of being hit from many different directions. Every Springer Nature journal has a open data policy now. So if you're going to get published in Nature and they say, hey, you need to make your data set available, you will make your data set available to get published in Nature. If your university has a policy, if your funder has a policy, these things all help. But not every country can move at the same rate, and not every institution has the support available. I think another big problem is this equity problem of ivory tower universities. We work with universities. They get a data repository powered by Figshare, and they have 10 people in the university working on it. 5 of them are checking the files. 5 of them are promoting and explaining to researchers how you use it and what licensing is. And we have some universities who have a data repository because there's a national mandate, but they have one person who can work 20 minutes on it every week in helping people, in answering support tickets and things like this. So it's really that balance of where the funding is and where the support is. I think there's 2 things with why people would be negative towards it or why people haven't caught up with it. We see China has an open access and open data policy. North America does as well. 52 funders around the world have an open data policy that you have to make your data available. Nearly every private funder of research has this as well. Some countries are just slower to move on certain things because of other priorities. Some universities are too, because there's a lot to do around that. Librarian could be working on engaging with researchers around ORCID or other priorities. So I think there's that. The future is already here. It's just on an evenly distributed kind of mentality. This is why I was saying Overleaf and working collaboratively and openly changes the space in just moving things along. We don't have to wait for people to die for the space to move along, which was the old kind of mentality of things, because the academic publishing setup and reward setup is very complicated, and there's lots of things that are confusing about it. And as I said, when I was a researcher, I had no idea what open access or closed access meant, right? I just wanted to publish papers because that's what I was told to do in order to advance my career. And so I think there's a lot of people who are still on that mentality of, yeah, open access and open science and open research is cool. And if you ask me about it, I'll tell you, yeah, that's good for humanity. Let's do that. Do you do it though? well, no, I haven't got the time, or, I've got a mortgage to pay, so I need to publish in the best journals, and the only way I can do that is to publish closed access and da-da-da-da-da-da-da. So I think there's still the legacy of old academic dissemination of content that is a hindrance to the mentality shift and the culture shift for academics around the world. And sometimes it's naivety, and sometimes it's, almost maliciousness.
Absolutely.
That's all the time we have today. Catch more of this episode in the next part with your host, Nikesh Gosalia. See you soon.